For this problem, we are asked to assign 4 different values at first. Each of these values would coincide with a different transformation later on for the following functions. For the first function, we are asked to use cosine inverse of x. So by applying the transformations, you would get this equation. We are then asked to find the domain and range of each of the functions. So for this function, you would to find the domain and range, you would look at the initial parent function domain. So that's -1 to 1, and then apply the b and the c values because those are the transformations that are applied to horizontal values on the xy coordinate, and they would alter the domain. So you would divide -1 and 1 by 5, respectively, because the 5 is a horizontal compression and smushes the period to make it smaller, making the graph more frequent, but making it look smushed together on a graph. So that would yield -0.2 plus 6. You do the plus 6 because you're moving the x values all over to the right by 6 units. So that's a positive increase, so you would add it, giving you 5.8. And then you do the same thing over here and get 6.2, but for 1 right here. And you get your new domain of 5.8 to 6.2. Now for the range, you do the same thing, but with the a and d values and the initial range of the parent function. So this range is 0 to pi, so you would take 4 times 0 because 4 in the equation is multiplied because it's the amplitude. So that would give you 0 minus pi over 8 because you're shifting the graph down by pi over 8 units. And then you do the same thing for pi, and you'd get 31 pi over 8. Now, for secant inverse, you do the exact same process as before, but with the initial domains and ranges of the parent function for secant inverse. So that domain would be -infinity to -1 to 1 to -infinity. By doing the exact same calculations up here for -1 and 1, you'd get 5.8 and 6.2, and that becomes your new domain of -infinity to 5.8 to 6.2 to infinity. You'll notice that these are actually pretty similar, and I'll talk about that later. Now for the range, you'll see that there's an extra value right here. There's no infinity, and that's because it's cut off just because of window issues and things like that. But this is actually a horizontal asymptote. So in the parent function, the range is 0 to pi over 2, pi over 2 to pi. Pi over 2 in this case would be the horizontal asymptote where secant inverse is undefined. So you do the exact same values for all 3 of these. So these 2 are the same for 0 and pi, but for this one you do 4 times pi over 2 minus pi over 8, which is just 15 pi over 8. And that would give you this new range. Now, you'll notice that the domain and ranges are actually pretty similar, and they have a lot of the same values, just slightly different because of the transformations. For the domain of each, you'll notice that 5.8 and 6.2 is constant in both of these, except that for secant, there's a jump from 5.8 to 6.2. It's not all through it. And that's because where cosine inverse exists, that means that all of those values will be between -1 and 1, or in this case, 5.8 and 6.2. And because of the nature of secant and that it's reciprocal, it can never exist there. The values for secant inverse will always be less than -1 or greater than 1. So it can't exist there, and that's why there's the jump right there. But it also explains why these 2 values are the same, because if you look at the parent functions, it's the same way. Now for the ranges, they're almost identical except for the presence of this pesky little horizontal asymptote. The reason this horizontal asymptote exists because in this equation, 15 pi over 8 would be where cosine inverse equals 0, or cosine really in general. Cosine would equal 0, and because secant is equal to 1 over cosine, secant in this case at 15 pi over 8 would equal 1 over 0, which is an undefined value. It's impossible. So that's why that graph is undefined and causing a horizontal asymptote. It can never be that value. It's the same way for in the parent function range, y pi over 2 and pi over 2. As we know, cosine of 90 degrees equals 0, so by extension, secant of 90 degrees has to be undefined.